Hi guys, my name is Sandra Nalin Bazoka Prophet, and today we are going to be talking about the nomenclature of aldehydes or alkana. Now, basically, there are two methods or there are two naming process of the alkana or of the aldehyde, and they are one we have the common system and the IUPAC system. Now, we're going to be interested in this video on the common system of naming of aldehydes. Now, in naming of the aldehyde with the common system, it is very, very simple. It is similar to the naming of the carboxylic acid, in which the case of the nomenclature of carboxylic acid, the IC of the carboxylic acid, which is the IC of the carboxylic acid, is replaced with former aldehyde. Take note, is replaced with former aldehyde, in which in the case of the first member of the carboxylic acid, which is the formic acid, the IC is removed with the acid and replaced with what we call the aldehyde. The aldehyde. Now we take some examples. Basically, we have 9 examples here to illustrate the common system of the nomenclature of the alkana or of the aldehyde. First one is, look at it. We have carbon here, which is similar to the formic acid. In this case, it becomes former aldehyde. So, right? Former, which is the isomer removed, so former aldehyde, common system. Now, what is the trivial name? Now, in this case here you have two carbon here with the aldehyde functional group here. So that becomes what we call the acetaldehyde. How do I know? From the acetic acid. Remember, we have the formic, we have the acetic acid. So take note. So here is formaldehyde now. Here from acetic acid, we remove the IC, we now put acet, then we use the word the aldehyde. Acetaldehyde. Now in this other case, here we have three carbon in the case of formic propionic acid. In this case here, it is what we call the propion. Instead of you putting IC here, in the case of carboxylic acid, they become propion aldehyde. If you realize in this case here, you observe that in the naming, it is similar to the naming system of the carboxylic acid. It's the same, very easy. Now, in this other case here, we have contain 5 carbon. 1, 2, 3, 4, 5, which is valeric acid in the case of carboxylic acid. Now here becomes okay, 4 here. So let me find somewhere to put it. Okay, let me clean one of them here. Okay, so I can put that name. So that becomes aldehyde. You can see aldehyde. They will then move straight away to. Now there is another system. There is another system of the nomenclature of the aldehyde, which is what we call using the alpha, beta, gamma system. Now look at it. If you look at this pattern here, you observe that the alpha designation is after the carbon carrying it's after the carbon carrying the oxygen atom, which is this carbon 9 here. So the first carbon that is closer to it we call the alpha, the beta, the gamma, the delta, and the epsilon. Now let us take some similar examples here. Look at it now. Now remember the longest chain too. So here I'm having 1, 2, 3, 4, 5, which is already a valar aldehyde. but we have a substituent here. So the substituents are in this position. So if you look at the substituent, the substituent is at what now? It's at gamma. If I have to name it, is number 5 here, it becomes gamma methyl, okay, val aldehyde. It's as easy as that. Then we then move to this other one, which is number 6 here. In the naming of number 6, take note, the longest chain here. 1, 2, 3, 4 is not, but 1, 2, 3, 4, 5. So this is 1, number 2, 3, 4, and 5. So we have the substituent at carbon 3 and carbon 2. So in naming it here, you remember that here is alpha, and here is beta. So it becomes alpha, beta, dimethyl, okay, val aldehyde. You see how simple it is right now. Now, in the case of 7, we have to name it. Now, look at it here. Here is, okay, here is alpha. Now, because this naming is a standard naming, there is no need for us to put the alpha. So here becomes the phenyl acetaldehyde. Why is it so? Remember, this is a phenyl group. Then these 2 carbon here is an acetal, which is an acid. So acetaldehyde, which is phenyl acetaldehyde. Now, another important system again is what we call, or another format again is what we call the formyl, which is another pattern. Now, a formyl can be used in place of the carbonyl, which contains the carbon doubly bonded to oxygen. So in naming this structure here is very, very simple. So what do? We come here to say, to number, which is 1, 2, 3, 4. So that becomes 4 formyl. See, benzene, which is the benzene structure, benzene, okay, sulfonic acid. And lastly, we move here. In naming this one, remember that this one is a formyl. So we call it, the number is 1, 2, 3. So here we become 3 formyl, okay, 3 formyl cyclohexene. Now, if you look at this naming, you will see that it is very, very easy. To understand more of it, try to watch it again, over again, to understand the rudiments about it. For now, this is the end of the common system. And our next video clip is on the IPAC system. Do well to subscribe and turn on your notification to get more updates when any of my video is uploaded. God bless you.